5, 6b. And this is the last lesson of Chapter 5. Okay, so 5's coming to an end. We will quiz on 5.5 and 5.6 on Monday. So we're going to talk about areas of triangles. Area of triangles. I'm sure you already know a formula for the area of a triangle. 1/2
BC.
1/2 base times height. Or maybe not. I don't know. So quiet. All right. So if you're given side angle side of a triangle, then we can find the area. So let's say that you have a triangle that cuts the quadrant 1 like this. And this is A, and this is B, and this is C. Probably shouldn't have wrote it like that, but whatever, it's okay. And then this over here is angle A, this is B, and this is angle C up here. Then we know that the area of the triangle would be 1/2 base times height, 1/2 BC. Okay? So that's pretty basic. But what happens is we are going to not have a right triangle sometimes, most of the time, right? So what they do is they go ahead and redraw it. So I want to show you how it works. And let's say we have this triangle. And this is A, and this is B, and this is C now. Okay? And then remember, that's going to be the height. Okay? So it's the height of the triangle. So area is still 1/2 base times height. So in this case, the base is C, and the height is H. But we're not given the height. We don't know what the height is, okay, of this triangle. Bless you. But what we can do is this. See this angle A over here? The sine of A is equal to what? Does anyone know? There's a right triangle right here. SOHCAHTOA. H over B. So that means that H is equal to B times the sine of A. So if I wanted to find the area of the triangle given side angle side, I go back and I plug it in for H right here. So the area would be 1/2 BC sine A. There it is. Okay? I could have just given that to you, and you would have just accepted it and believed me. But I wanted to show you where it comes from. So that's where it comes from. So area equals 1/2 BC sine A. Also, all the other ones work too. 1/2 AC sine B. Okay? So whatever these sides are, this will be the angle between them. SAS, side angle side. Yeah.
How do you tell the difference between area and not area? Area and angle A.
Area and what?
Angle A.
Ooh, good call. Sometimes they'll put a little triangle right there. So the area of the triangle. Yeah.
Why don't they just put like the little like
Oh, not there.
this?
Yeah, I don't know. But I'm glad you said that because you're right. It looks like angle A instead of area. Good call. Okay, so let's do one. Number 1. We'll do an easy one, then we'll do a harder one, okay? Yay. So let's suppose that we have a triangle. Here's our triangle. And this angle right here is 102 degrees. It's hot. And this is 52 meters. And this is 90 meters. And we want to find the area of this triangle. Find the area. Okay, this one's nice. I mean, it's all set up for you. Okay, sometimes you might have to find, like when you're doing this area formula and they ask you to do this one, you need side, angle, side. And if you don't have that, you know how to find all the pieces of a triangle so you could find it and then use the formula. So here we go, area equals. So area of the triangle equals 1/2 BC, so times the sides, 1/2 each side, 52 and 90. So each side on the other side of the angles. And then it's sine of 102. Okay? I think the biggest mistake people will make on this on the quiz on Monday is they'll put cosine of 102 on accident. It's sine because the sine is h over b. All right, and then you go, you get your calculator out. Make sure that you are in degree mode for this. I changed to radians yesterday because I was in calculus using radians. So it's 0.5 times 52 times 90 times the sine of 102. And so you get 2,288.9 square meters. Area is always square units. All right, pretty easy so far? Yeah? Okay, let's do number 2. Ooh, this one's kind of fun. All right, it says to find the area of a regular octagon, inscribed in a circle of radius 9. Inscribed in a circle with radius 9 inches. So funny, I was reading a book to my son about cheetahs, and it said that cheetahs can have like 4 cubs at one time. And then my son goes, how many can a person have? I'm like, well, there was Octomom. She had 8 at one time. All right. Find the area of a regular octagon inscribed in a circle. That's so random. Here we go. Here's a circle. Radius 9. That's pretty good. And we need to find this octagon. So what we're going to do is an octagon has 8 sides, right? We need to figure out what each triangle is going to be. Because you can take an octagon and you can split that up into triangles. You know that, right? A regular octagon. So like, for example, if you have, well, let's do this first because I want to see how much the area or the angle measures are. So if you take 360 degrees and you divide that by 8, then the central angle of each triangle in this octagon is going to be what? 45 degrees. 360 divided by 8. Okay? So here's what I'm going to draw. I have this, and I know where 45 degrees goes. It goes to there. And then I can draw this. So these are all going to be 45 degrees, and that's going to make my octagon that's inscribed in here. I wish I was a little bit better of a drawer, but this is okay. So do you see the octagon inscribed in this circle?
Yes.
Good. Is yours better than mine?
No.
Oh, okay, good. So these are all 45 degrees. Okay? And the radius, in this case, the radius is going to be both sides of your triangle that's in here. So the radius is 9 here and here. Sometimes the radius goes in the middle of it, and that gets a little bit more complicated. Okay? All right, so now we're going to find out the area of one of these triangles. So we'll find the area of one of the triangles, and then we'll just multiply by 8 because there's going to be 8 of them. And it's a regular octagon, so everything's the same. Okay, so let's find the area of that triangle. So we will use our area formula that we just learned. So, because we have side, angle, side. So 1/2 9 times 9 times the sine of 45. And they want this in, they don't want this as a rounded answer. We want exact values for this. Okay? So in other words, you can't just plug this into your calculator. You have to know what the sine of 45 is. All right, so we're going to go 1/2 times 9, which is 81, times the sine of 45. What is the sine of 45?
Rad 2 over 2.
Yes, rad 2 over 2. Perfect. Okay? Wait, did I do that right?
Yes.
Yeah. All right, so then we get 81 rad 2 over 4. So we're multiplying all these together. So 1 times 81 times rad 2, 2 times 1 times 2. But that gives me one triangle. And so don't forget at the very end, you need to multiply this whole thing by 8. There's 8 triangles. And so we get 81 times 2, which would be 162 rad 2 square inches.
Why is it 8 squared?
Oh, no, I went 4 goes into 8, and I got a 2 there. Sorry. There you go. And they'll want it in exact answers, so make sure you leave it in radical form. It was a little tough, huh? A little harder one? Okay, so that's part A. That's the 1/2 of AB sine C. Now let's do part B. And this one is for the side area formula. Did you have a question on the last one? No? Okay, so when we're given the 3 sides of a triangle, we can find the area. This is called Hurons formula. Have you ever heard of Huron? Yeah? You have? Who was Huron? Does it say what his formula is all about? Me too. When was he? He was a long time ago, right? It doesn't?
No.
I probably learned about him in the history of math class. Oh, here we go. The formula is named after Huron of Alexandria, whose proof of the formula is the oldest on record. Yeah. What?
That means he could have stolen his answer.
No.
Yeah, it does. It just means that's the oldest one on record. Somebody else could show that. He's so old. So old.
Oh, yeah. It says he might have stolen it from Archimedes,
Ah, wow.
who was considered to be the greatest mathematician of all of antiquity. Okay, here we go. Huron's formula. Now, Huron's formula, you have 3 sides of a triangle.
You're on something.
No, he sounds like a hero.
No, he stole the formula.
Yeah, they all do. Pascal, it's not Pascal's triangle. It's not.
Whose triangle is it?
A Chinese man's.
Is it really?
Yeah. Yep, look it up. Okay, here we go. Here's a triangle, ABC, and we know these. And so Huron's formula says to find the area of this triangle, what you're going to do is you're going to take the square root of S times S minus A times S minus B times S minus C. And you're probably wondering what S is, because you need to know that. So you know that the sides are A, B, and C. So what is this S thing? Well, S is called the semi-perimeter. Semi-perimeter. And what the semi-perimeter is it's just half the perimeter of the triangle. So S is equal to A plus B plus C, but half of that. So S stands for semi-perimeter, not the P. It wouldn't be P in here. It's not perimeter. It's half of the perimeter. And that's the formula. Okay? So if you know that, and you know this, you'll be fine. I don't know if there's a proof of this in the book. Do you need a proof? Or you just accept it?
It'd be cool.
It would be cool. I don't know if I've ever proved that before. I might have in college. Number 3.
Do it.
No, but I don't know. I'd have to, like, really think about it. So, what's that? So, square root of all that. So, let's do one. So, let's say that they tell us that side A is 13, side B is 15, and side C is 18. Okay? And we need to, and let's say you forgot Huron's formula. You could use side, side, side and try and find the angle between and use 1/2 AB sine C if you knew that one. So you know how to find all these parts of a triangle, so it doesn't matter which area formula you use. I like to just use the easiest one. So if I'm given 3 sides, I just plug it into Huron's formula and I'm good to go. All right, so here we go. Let's do it. Area is going to equal. First, I need to find the semi-perimeter, okay? So S is equal to 13 plus 15 plus 18 all over 2. And if you're going to put that in your calculator, make sure that you do parentheses around the top 3 numbers. 13 plus 15 plus 18, all of that divided by 2 is 23. 23.
Oh, already over 2.
Yes. All right, so now it's going to be the square root of 23 times, so the semi-perimeter times all of them minus each side. So 23 minus 13, 23 minus 15, and 23 minus 18. I know, right? This was back like in 200 BC, like it's, or something. No, maybe not. Yeah, that's what it says. It was a long time ago. This one's been around for a while. Why did they need that, though?
You had too much time.
Well, they didn't have Xbox or Broadway Showcase or... Yeah. They were bored. What else are you going to do besides math? I'm sure women weren't allowed to do any math either. Probably not.
It's probably a women's formula.
Yes, the women figured it out when they were making crescent rolls or something. Okay, so you plug all that in. Anybody get it? Anyone? I got 95.9, yeah? Uh-oh. 95.9, the fish. All right, I didn't actually subtract these because, you know, I'm bad at subtraction. I actually just plugged it all in with parentheses and everything. Yeah, it's so cheesy, huh? Okay.
Just make the formula in your calculator.
Ooh, yes, you can make a program. Ask Peyton Coy, he'll make one for you. All right.
You can make one?
Number 4. You could go online. I could probably do it, yeah.
You can, they're not gonna have to make.
No, they're not. I took a programming class in college.
You don't even have to do that.
I did.
I know, but you don't have to, like...
You could go online and put a link to your calculator and download a bunch of formulas. It's probably on there. I'm totally going to do that later. Okay. Find the area of a parallelogram. Do you know what a parallelogram is?
Yeah, I do. Rectangle. No, it can be slanted, though. That's why you can't assume that it's 90 degrees.
Parallelogram.
I think there's 2 L's.
Parallelogram. I think that's it. Pass?
Parallelogram.
There we go. Okay. Find the area of the parallelogram, given that the sides are 17 and 28, and that the diagonal is 35. This is pretty easy. These can get a little complicated, these parallelograms. Okay, did you want to draw a parallelogram? I do. No?
I do.
Parallelogram. It's like a rectangle but slanted. Right? That's pretty good.
But a
So,
rectangle can be a parallelogram.
true, yes. No, wait. Yes. I always hated those. All squares are rectangles, all rectangles are squares. True or false?
I love those.
You do? Oh,
Yeah.
hated those. All right, 17, 28. The diagonal, 35. So we know that parallelograms, the sides, the parallel sides are exactly the same length. So this is also 17, and that's also 28. Yeah? Oh, they tell you that. Oh, this way? It would be the same, right? Wouldn't it? Or no? No, that looks like it would be longer that way, huh? Oh, yeah. It's a good call. It really wouldn't matter, though. Yeah. I drew it that way because one of them is going to be it, so I can make some triangles out of this. So now if you look at this, you have 2 triangles, that one, and you have that one. And they're exactly the same. Okay.
It looks like a grilled cheese sandwich.
Does it? Oh, okay. All right, so let's find the area of one of the triangles using Hurons formula because we have side, side, side. So the area of the triangle would be, let's find the semi-perimeter first. Semi-perimeter is 28 plus 35 plus 17, all divided by 2, 40. Did you get 40? So we're going to do the square root of, bless you, 40 times 40 minus 17 times 40 minus 28 times 40 minus 35. Okay? So, 40. It's not a race. I'm going to win, though. All right. So what'd you get? Me too! 234.9? 234.9 units squared. They didn't tell us what kind of units it was. So that's the area. Done. Okay, so you have a quiz on Monday. I know that's a bummer. I'm not even going to see you till then. That's a long time. Thursday, Friday, Saturday, Sunday. Whoa. Let's talk about what you're going to need for your quiz. Well, you're going to need to memorize 4 formulas. 4 of them. You need law of sines. That one's easy, right? You know that one pretty good? Law of sines. You also need law of cosines, and there's 2 of those to memorize. And then you need side angle side area formula, which you learned today, and side 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 Hurons formula, area of a triangle. And those are the things that you're going to need.
We need to know the S equals whatever.
Yeah, that'll be part of this area formula here.
Okay.
Mm-hmm.